Okay, so in the last video we have seen that what are the owner and user responsibilities as per the API 570 code. Now we are going to move towards the fifth section of this code, which is going to be the examination, inspection and pressure testing practices for piping systems. Now this section can be considered as the heart of what the API 570 is trying to tell us. This will lay down all the requirements that authorized piping inspector will require when he is inspecting the piping systems. So, inspection plan, piping system and circuitizations. The first thing we have to understand, if there is an organization which has multiple pipes installed at their organization, then it will be really tedious work to check each and every pipe for all the different details. Okay, so just to make our lives easier, the piping systems should be circuitized. The meaning of circuitization is the similar pipes will be similar pipes in similar service, similar operating conditions, similar flow characteristics will be considered into one piping system and they are processed accordingly. Okay. So in order to develop the inspection plan, including scope, frequency, techniques and location, facility piping should be broken down into multiple piping system and piping circuits. Piping systems can be defined at a process flow diagram level or PNID diagram level, that is piping and instrumentation diagram level, but in most cases the piping circuits are going to be defined by PID diagrams. Potential damage mechanisms are primarily a function of the process and operating conditions. That means what kind of process it is. If it's a pipe that is carrying caustic, if it's a pipe that is carrying hydrochloric acid or something like that, it's the primary function of the process and operating conditions, the material of construction and mechanical design. The defining systems and circuit based upon the potential damage mechanism can yield an inspection plan with a high probability of detecting damage. The piping systemization is first cut into for defining the potential corrosion issues and convenient references to general location of damage mechanisms within the process pipe unit. Okay. Now, the piping systems generally have common characteristics such as following: process intent, process control scheme, process steam composition, design operating conditions, and similar or related in IOWs, that is integrity operating windows. Piping circuitization is further breakdown of a piping systems into sections of pipe or individual pipe components which have common damage mechanism, same materials of construction, and have similar damage rates and damage modes. So just to make our life easier, we are classifying or we are dividing the pipes into different circuits and different systems. So the common operating condition, common damage mechanism will be considered into one. So the analysis will also be the same for all of those systems in a single circuit. Okay. So API 574 will give you much more detail about how to do piping circuitization. We'll talk about this when we'll go to API 574. Next is development of inspection plan. The inspection plan shall be developed by the engineer or the inspector. A corrosion specialist shall be consulted to identify, clarify the potential damage mechanism, specific locations where degradation may occur, especially where localized or cracking mechanisms may be involved. So sometimes a special corrosion analyst is also needed, or corrosion engineer is also needed, or a specialist is needed, so that he can tell you that what kinds of potential damage mechanisms are present in that circuit if there is some localized cracking or localized corrosion that is happening. A corrosion specialist shall be conducted when developing an inspection plan for a piping system that operate at elevated temperatures above 400 degrees Celsius, and the piping system that operate below ductile to brittle transition temperature. So this is generally the case which can be identified by impact testing. So in those cases, the corrosion specialist may need to be consulted. If not, if the inspector is knowledgeable enough, he can generally do it, but generally a corrosion specialist would be needed. Okay. Piping system shall be evaluated based on the present or possible types of damage mechanisms, the method and the extent of non-destructive examination calculated to assure that they are adequate to identify the damage mechanisms and the severity of the damage. First of all, we already know that not all kinds of non-destructive testing can tell you every defect. So you first need to understand that what kind of damage mechanism is possible. Second, you also need to understand that whatever non-destructive testing that you are doing, is it capable of identifying the damage mechanism or not. The examinations can be scheduled at interval that consider type of damage, rate of damage progression, tolerance of the equipment to the type of damage in question, capability of non-destructive testing methods to identify that damage, maximum interval as defined in codes and standards, extent of examination, recent operating history including IOW exceedances, management of change record that may impact inspection results, and RBI assessment or pipe classification. Okay. The inspection plan shall be reviewed and amended as needed when the variables may impact the damage mechanism or deterioration rate as defined, as such as the contained in the inspection report, management of change document. Again, API 574 will give you much more detail about how to develop the inspection plan. So, what should be the minimum content of the inspection plan? What are the things that you should at least have in your inspection plan? The plan shall contain the inspection task schedules required to monitor and identify the damage mechanism and assure the pressure integrity of the piping system. The plan should contain and it should define the type of inspection needed. That is, if you need an internal inspection, if you need an external inspection, or if you need an on-stream inspection or thickness monitoring. Okay. Next is, you'll also have to define that what should be the next date of inspection at the inspection itself. So if I'm doing inspection today, I also need to mention that what should be the next date of inspection for the same equipment. Describe the inspection method and non-destructive testings required. Describe the extent and location of the inspection at ND and NDE at CML. So what type of non-destructive testing methods are required at different condition monitoring locations. Okay. Describe surface cleaning requirement needed for inspection and examination of each type of inspection. Describe the requirements of any pressure test that is needed. Describe any required repairs of known or previously planned before the upcoming inspection. Describe the types of damage anticipated or experienced by the piping systems. Define the location of the expected damage and define any special access or preparation needed. Generic inspection plans based on the industry standards and practices may be used as a starting point in developing the specific inspection plan, but the inspection plan may or may not exist in a single document. However, the contents of the plan should be readily accessible for the inspection data system. That means a generic inspection plan can be used, but depending on the conditions, we need to understand that we might need to make some modifications on that inspection plan, which is generic for your certain application. Okay. Next is risk-based assessment.